A running lion can make a leap 10 meters long, reaching 3 meters high, and we want to calculate the lion's initial velocity and the angle that it leaped at. So this is one of those like really annoying questions that your professors ask that is only worth 1 point on the exam and it takes you 30 minutes to complete. So there's multiple steps with this question. Okay, so first thing we want to do is we want to write our knowns and draw a picture. So we can draw a picture first. Okay, I'm not going to do a mountain line. I don't know how to draw. This is our mountain line. It's a stick figure and lying down. Okay, so we have the mountain lion. It is leaping 10 meters wide. And it leaps 3 meters high. And that is realistically all the information that we have. So we have to break this up in its x and y components. So we'll start with the x component. So net forces in the x. We have acceleration only happening in the y. So we'll just write that down. So negative acceleration with gravity. There's no acceleration acting in the x. We do have displacement. Displacement is 10. It's given in the question in the x, and displacement in the y is 3 meters. Our initial velocity is what we're trying to solve. So this question, I'm just going to start with this. We have to break this up in two separate parts. So the mountain lion, it leaps up. So there's an initial velocity on the way up. And it slows down until it finds its final velocity of 0 at the top here. And then it decreases. Initial velocity accelerates again, but in the negative. So final velocity at the top is 0. And then there's time. Okay, so in the y direction, in the y component, we have 3 pieces of information. So what kinematic equation can we use? We can use this one. And we'll use it to find initial velocity. So v final squared is equal to v initial squared plus 2 acceleration and displacement. Okay, so final velocity is 0. V initial squared is what we're trying to solve. 2, 9.81, and 3. Okay, so we have 2 times 9.81, negative 9.81 times 3. And then if I subtract it on both sides, or add it on both sides, this will give us 58.86. We'll square root it. So we have 7.67. So our v initial in the y is 7.67 meters per second in the y. So we'll erase this to give me some space. And we could use that information actually to find time, and that's how we will connect it with the x component. So let's use this formula. V final is equal to V initial plus acceleration time. So V final is 0 again. So now we have our V initial 7.67 plus acceleration. So we'll subtract 7.67, and we have negative 9.81. So our time is 0.78 seconds. So this time, I want to be specific, is only to this point at the top here. This is 7.67, sorry, 0.78 seconds, 0.78 to make it to the top. And be mindful, so it took 0.78 seconds to make it to the top, so we can assume that it will take that same amount of time to make it to the bottom, to make it its complete 10 meters, the running mountain line, to make it its complete 10 meters. So we can multiply this by times 2, and this will be 0.56 seconds. So it took 1.56 seconds for the mountain lion to reach 10 meters. So 1.56 seconds. And now we have 3 pieces of information. So we can use the kinematic equation to solve for the initial. We can use this one. Oh, this one's actually not that bad. So displacement is equal to V initial time plus half acceleration time squared. And in the x direction, acceleration 0. So this is, we can get rid of that. Actually, this is just going to be 0. So we have displacement, which is 10, the initial, and we'll divide by time, which is 1.56. So our V initial is 6.41 seconds. And so we have V initial in the x and y, and we just use Pythagorean theorem. You guys remember this to solve for the hypotenuse. As we have the x, let's just write it out for you guys real quick. So we have the x and then the y, 7.67. This is in the y, 0.41. And we want to solve for this. So we have 6.41 squared plus 7.67 squared square root equal to c. I did something wrong. 1 moment. (9.99). So the initial velocity, to answer the first question, when it first leaped, it's 9.99 meters per second. And we can use this same information here to actually find the angle. If you guys remember SOHCAHTOA, we'll use TOA in this example. So we have tangent theta, and this is the opposite, 7.67 over adjacent. And we'll do the inverse tangent. So our angle is 50 degrees. Thank you for watching.